All right, so here we are with the remainder and factor theorems in lesson 4-1b here. Uh-oh, what did I just do here? Oh, there we go. All right, so today we're going to take a look at what's called the remainder and factor theorem. So we're going to start off with some examples here and talk more about this, but basically we want to know the relationship between the remainders of polynomials and evaluating a polynomial at a particular value, and how those factors and solutions are related to each other. Okay, so this is going to be fairly obvious when we see this first one here. So the first one says given f of x, and it just gives me this fourth degree polynomial. What is f of -2? Well, that should be easy. All I got to do is plug in -2 everywhere I see an x. So that'd be 2 times -2 to the fourth plus -2 cubed minus 3 times -2 squared minus 5. And if we do the math on that, we're going to end up, and I would encourage you to do the math by hand, but basically we end up with, well, I'll write out the terms. This is 32 minus 8 minus 12 minus 5, and we end up with f of 2 equals +7. All right? So all I did was I plugged in 2 to the polynomial and I got an answer, which also implies that I have a point on the graph at -2, 7. All right? Now, it says take the same polynomial on the right side and divide it by x plus 2. So I'm going to do this with synthetic division because I think synthetic division is easier. So I'm going to do x plus 2 equal to 0. That implies that I'm going to be dividing by x equals -2. I'm going to list out my coefficients. I've got a 2x cubed, x to the fourth, a 1x cubed, a -3x squared. I'm missing an x term, so I need a 0 there. And I've got a -5. And I put my little upside down L thingy here and a place for the remainder. All right, drop down the 2. Here we go. 2 times -2 is -4. Adding the column, you get -3. -3 times -2 is 6. Add down the column, you get 3. 3 times -2 is -6. Add down the column, you get -6. -6 times -2 is +12. Add down the column, and I get a remainder of 7. Remainder of 7. Now, if you look at what I just did there, the 7 remainder that I got is exactly the same as the answer that I got in the first part over here on the left. So what we're saying is that f of -2 is equal to 7, which is equal to the remainder in synthetic division. So if I want to know, for instance, if x plus 2 is a factor of this polynomial, without doing all the division, I can just plug it in and see if it comes out to be 0 or not. If it comes out to be 0, that means I'm going to get a 0 remainder. Okay, let's take a look at the next one and see. All right, so I've got a fourth degree polynomial that says what is f of 4? So we need to change these guys here to -20s. Not sure why those are +13s. So we're going to change those to -20. And notice I did it on both sides of example number 2. And so we're going to find f of 4. So f of 4 is equal to 4 to the fourth minus 6 times 4 cubed plus 8x squared. Oops, I forgot the 4 in there. 8 times 4 squared plus 5 times 4 and minus 20. Now, if we actually do all the work on this guy here, you're going to end up with f of 4 equal to 0. Okay, this time I didn't put all the terms down there, but f of 4 does equal 0 here. So when we go to look at this, we've got to, when I go to divide by x minus 4, I better get a 0 remainder. What this is telling me here this is telling me that I have the point 4, 0 on my graph. Okay? Which means that if I'm going to divide by x minus 4, that it better divide out with a 0 remainder. Let's take a look. X minus 4 equal to 0. Add 4 to both sides. We're going to divide by x equals 4. And we're going to start off with, what do we got here? 1, negative 6, positive 8, positive 5, negative 20. No missing terms there. So we'll add these guys in here, give our little remainder area here, drop down the 1, and we'll start multiplying. 1 times 4 is 4. Add down the column, that's negative 2. Negative 2 times 4 is negative 8. Add down the column, you get 0. 0 times 4 is 0. Add down the columns, you get 5. 5 times 4 is 20. And there's our 0 remainder. Okay? So what this is telling me is that because 4, 0 is a point on the graph, okay? So because 4, 0 is a point on f of x, okay, then x minus 4 is a factor of f of x. Okay, so there's some cool stuff going on here with synthetic division and just plugging stuff in. All right, so and when you think about it in the more general terms, okay, what do you notice when you evaluate f of h and divide f of x by x minus h? Okay, basically, f of h will always equal the remainder when dividing by x minus h. Okay, and you can see that up above. We got a, when we plugged in 4, we got 0 out. When we divided by x minus 4, we got 0 as a remainder. Okay, so the value of f of 4 will always equal the remainder when we're dividing by x minus 4. Okay, pretty cool. All right, let's go on to example 3. All right, so we want to solve this equation. So now we're going to use all these things we've been talking about to solve the equation by factoring. Okay, so we're going to start off by looking back at some stuff we've already done. I don't have a factor for this, so I don't know what to divide it by, so I have to go back to my other factoring methods. Number 1, is there a common term? Number 2, is it a difference of 2 squares? Number 3, is it a trinomial? Number 4, is it a third degree polynomial with 4 terms? Yes, it is. If it's third degree with 4 terms, I'm going to try and factor this by grouping. It's going to be my first thing to try here. X cubed minus 3x squared. Group those up. Negative 9x plus 27. Group those up. Throw a plus sign in between. I'm going to keep the equal 0 on there because we are solving this and I don't want to forget about that later. In the first set, I can factor out an x squared and I'm left with x minus 3. In the second set, I can factor out a negative 9 and I'm also left with x minus 3. Now, what I'm actually doing at this next step is I am factoring out an x minus 3 from this set on the left and from this set on the right, just like you would factor out any other common term. So I factor out the x minus 3. It essentially takes it away from both of those terms, and what's left is x squared minus 9 equal to 0. All right, now at this point, I can do one of two things. I can continue to factor x squared minus 9, or I can just take these and set them equal to 0 because I know I can solve x squared minus 9 with some square roots and that kind of thing. I think the last time I did it with square roots, so this time I'm just going to factor it. So I have x minus 3 times x Now I'm factoring x squared plus minus 9, that's x minus 3 times x plus 3 equal to 0. So there are my 3 factors, and here are my 3 solutions. The first one would give me a solution of x equals 3. The second one would give me another solution of x equals 3. The third one would give me a solution of x equals negative 3. Okay? Now, I'm sure you talked about this in Algebra 2, but it says to list each factor and its solution. So I have a factor of x minus 3 and a solution of x equals 3. I had a second factor, obviously x minus 3, and a solution of x equals 3. My last one was x plus 3 and a solution of x equals negative 3. So part of what we're talking about here today is the relationship between factors and solutions. Okay? If I have a factor of x minus 3 and I set it equal to 0 and I solve it, you know, if I were to do this to each one of them, all right? There's the factors, each set equal to 0. If you solve those, the solution to the factor is the opposite value of the factor. Okay? The solution to the factor, or I should say to each factor, is the opposite what should we say here? Opposite value of the factor. Okay, so if you already knew that, that's great, but you need to understand that going forward here, because in the next case, we're going to take a polynomial, p of x, okay, so instead of f of x, we're just using p of x, and we're going to say that this polynomial has solutions of x equals negative 4, x equals 1, and x equals 5 halves. And the first thing it tells us to do is write each solution as a factor with integer coefficients. All right? So we need to think about this. If I have a solution of x equals negative 4, and I want to put that back in factored form, that means the 4 has to go back with the x. So I'm going to add 4. That gives me x plus 4 equal to 0. So that's what the factor would have looked like before it was solved. I would have had one factor of x plus 4. All right? So I'm just going to drop that down here. And I'll put it up here for x plus 4. My second one is x equals 1. X equals positive 1. Well, if we subtract 1 on both sides, we get x minus 1 equal to 0. There's my second factor, minus 1. And my third one is x equals 5 halves. Now, I don't know about you guys, but at this level of mathematics, we don't see factors. Imagine if you were to subtract 5 halves from both sides. Okay, we would see x minus 5 halves equal to 0. Now, the only problem with that is we don't usually see factors with fractional numbers in them. They're always integers, like plus 4, minus 1. So in order to solve this guy here, we need to get rid of that fraction. And the only way to do that is to multiply it by the denominator. So I'm going to take this guy right here, I'm going to wrap it up, and I'm going to multiply it by 2 over 1. That's going to give me 2x equals 5. And now I'll subtract the 5 on both sides, and I get 2x minus 5 equal to 0. So my last factor is 2x minus 5. Now, why is that important that you do that? Because if I would have used the other factor, if I would have used x minus 5 halves equal to 0, I would never have known that this polynomial is actually going to end up with a lead coefficient of 2x cubed. And you'll see that in a minute because we're going to multiply these guys, but that's all I'm trying to let you know is if you don't do this particular multiplication by the common denominator up here, you're not going to get the right lead coefficient for this polynomial. You'll get the right degree and the right solutions, but it won't have the right coefficient. All right? The next step says to multiply the factors and write the polynomial in standard form. So all I want to do now is multiply these guys. X plus 1 times x minus 1 times 2x minus 5. All right, so here we go. We don't do all three at once. It's a lot easier if we just start with two of them. So I'm going to start with these two guys here. This is going to be x squared minus 1x plus 1x. Ooh, those two middle terms cancel out, and I get a minus 1. Uh-oh, what did I do here? That was supposed to be x plus 4. My bad here. All right, let's start this over again. X times x is x squared. X times negative 1 is negative 1x plus 4x. So that's going to give me plus 3x in the middle term. And then minus 4 at the end. So there's my first two. And then we're going to multiply those guys by 2x minus 5. Now, if you're more comfortable, you can put the 2x minus 5 in the front, but I actually like leaving the binomial in the back. So here we go. X squared times 2x is 2x cubed. I'm going to list all of these. X squared times negative 5 is negative 5x squared. I'm done with the x squared, I go to the 3x. 3x times 2x, positive 6x squared. 3x times negative 5, negative 15x. Done with the 3x, I go to the negative 4. Negative 4 times 2 is negative 8x. And negative 4 times negative 5 is plus 20. Combine your like terms along the row. 2x cubed minus, oh, looks like we're going to have a plus x squared. Is negative 5x squared and 6x squared. Negative 15 and negative 8x is going to be negative 23x plus 20. And it did say to write the polynomial in standard form. And depending on how the question's worded, it might imply that we want it like this, or y equals would be acceptable as well. Okay? So if I know what the factor is, x plus 4, then I automatically know what the solution is. If I know that the solution is x equals negative 4, then I know what the factor is. I know that if x plus 4 is a factor, then negative 4 is going to substitute into the equation evenly and give me 0 when I plug it in. In other words, it's an x-intercept. Okay? All right, so our factor theorem says if P of C equals 0, so some value of C, whether it's 1 or 2 or negative 3 or whatever, then x minus C is a factor of P of X. That's what we talked about on the front side there. In example number 2, I believe it was, when that binomial divided into the polynomial evenly, then we automatically know that x minus c is a factor. And because x minus c is a factor, if I take c and plug it in, I'm going to get 0 out for the answer. In other words, I have a point on this graph of c, comma 0. It's an x-intercept. Likewise, if x minus c is a factor, then I know that P of C will equal 0. Same case as number 1, only in reverse. Okay? All right, there we go.